No, I can't sign into my Google account in any way.
Okay. Secondarily, we're live.
Okay. If anyone knows my Google password, no, I'm just kidding.
It's what was the one I said the other day? Oh God, I'm getting telemarketer calls. What we're doing. Hello, dearies. Welcome to Undersampled Radio, episode 73. It is a very special episode today because although Matt is wearing a very maritime, nautical, thick, fleecy, cozy-looking sweater,
yeah.
Ethan Rosenthal and I are chilling, literally, in New York.
Hey, everybody.
Hi, Ethan. Welcome to the show.
Thank you.
I'm not going to really actually introduce you because this show might put you on the show the most times out of any of our guests.
Am I winning right now?
Is he tied with Chris Jackson, or is he?
We need a bar chart.
Yes.
I'm unsure where things stand.
We don't track data.
No.
It's not like it's terabytes. So I wanted to start off by saying that it's been fairly busy up here. My trip to New York, I've been doing a lot of work and things. So I told Matt there were no show notes. And then 5 minutes before the show, I wrote some show notes. So this is how I'm just going to give you the lowdown here. This is how this show is going to go.
Okay,
I'm
cool.
Talking, and we're going to say hello, right? I'm going to tell you a couple news bullet points.
Okay.
Then I'm going to ask Matt to tell us his news bullet points, and he's going to say, well, there's not really too much going on. Then I'm going to tell Ethan to run through the entire list of what a recommender system is and the various facets thereof. And it's going to be really interesting. And then we're going to ask each other what we're reading, and then we're gone. So that's our show, folks. Number one, it's blizzard time. My flight out tomorrow is likely to be canceled.
Huh.
Because we're getting 12 inches now as the forecast.
Whole bunch, right when you're leaving, too.
Directly ahead of my flight.
But at least you had a good flight in.
My flight in was delayed 11 hours.
When did you get in?
Saturday at 2 a.m. I mean, Sunday at 2 a.m. Yeah.
Wow, that's a gross time of day to arrive.
Well, it was even grosser being delayed in the Dallas-Fort Worth airport.
Oh, no, you were delayed. Okay.
11 hours delayed. No traffic at 2 in the morning.
Well, it can't have been snowing in Dallas. What was that all about? Just you didn't fly United, did you?
There was a bomb cyclone up here.
Okay. We've had no snow. Like normally when it comes through New York, maybe we will get it this time, but this winter's been dry. Well, it's been a bit rainy, but I haven't been skiing once, let's put it that way.
Man.
But now, oh yeah, we've got periods of snow coming. I don't know, Thursday.
The punchline to that story is that if you listen to this show and you're in New York City and you'd like to hang out, give me a ring. I'm on the Software Underground at softwareunderground.org.
You'll be stuck here indefinitely.
Yeah. Okay, bullet number 2, South by Southwest starts on Friday.
Have you been to that before?
Never have.
Okay.
So the point of that story is that I want to know your opinions of South by Southwest. I've been interviewing my Austin compatriots, ones who are veterans of the South by Southwest experience. And there's a tech conference. There's a music thing. There's a video, a movie thing. It's a whole bunch of stuff. Anyway, I'm going, and I mean, assuming that I'm not still in New York.
Yeah. Have you been? Have you ever been, Ethan?
No, I've never been. Never been to Austin.
What?
Period.
What?
Yeah.
Oh yeah. No, man, you need to go to Austin. It's good.
I know somebody to visit.
Yeah.
It's nice. Go to SciPy. Are you in Python most of the time?
Solely Python.
Okay. Oh, you need to go to SciPy. It's great.
Yeah, I do actually, and that's this summer. I should totally go, and I should get my company to pay for it, and I should make it happen. Yeah.
Yeah, it's really worth it. As I go on at length about that. I've heard. My impression. I've never been to South by Southwest, so I can't really talk about it. But my impression was that it started off really awesome and cool, and then got really massive and I guess commercial and just huge. I noticed once. Maybe I was thinking about looking at Airbnb, and sort of regular houses are like $2,700 a night, stuff like that. So not going, but I mean, it's obviously a big conference for getting all sorts of traction in social media and blogging and, Web 2.0 when that was a thing. I don't know what version we're on now, but so I don't know. Is it still a massive thing? Is Austin like all a buzz?
Yes, indeed. Streets are shut down. Downtown is the barricades are sitting on the side of the road so they can just shut all the streets down. It's huge, and it goes on for like 2 weeks. So,
okay. Well, when I was there the other week, I asked someone about South by Southwest, and they said it's a music festival, which I hadn't really appreciated before because I thought the big music festival is the other one, which I can't remember the name of.
City Limits.
Yes, City Limits. So I don't know, but it sounds like the tech's all still there. So you're going to go to some things, non-music things?
Yeah, I'll go to some music things too. I'm mostly interested to kind of poke around the tech conference to see who's there and shake babies.
So speaking of Austin, New York connection.
Took me a second.
Oh my god,
it's been a long day.
I just read about Brooklyn barbecue. Did you see that on Twitter this week?
I did see that on
this
Twitter.
weekend. Is that so? What is Brooklyn barbecue, and why is everyone so outraged about it?
I don't think it's a thing. And
oh, really? Okay.
People are outraged that some news medium tried to make it into a thing. And as a newfound Austiner, you should probably be offended by that. Austinite? Is that the preferred nomenclature?
We'll edit that part out.
Okay.
Yeah, last thing I want to do in New York is eat barbecue. I'm not like a huge barbecue eater, and there's so much barbecue in Austin that I'm a little bit saturated.
Yeah.
Saturated fat.
Yeah. I think the gist of it was that there's this barbecue sort of wave spreading out from the United States into fancy restaurants all around the world, but it's Brooklyn barbecue that's riding the crest of this wave. And I guess everyone in apparently Austin and Kansas City, which I'd never heard of the connection with barbecue, but apparently Kansas City is a big barbecue place. Everyone's up in arms because it's fake or lame or both or all three. So anyway.
Yeah, it's not Southern, right?
Right.
Midwest, where all the cows are. It's just Brooklynites co-opting this. But I think people from Brooklyn probably think that everything starts there, and that they're at the crest of the wave, and everybody else is paddling to catch up. So I think it all makes sense.
Yeah.
Hey Matt, tell us your bullet points. Your news bullet points.
Did you write any for me?
Yeah, let me find you.
No, we're doing a lot of teaching right now, and I can't read that. Oh yeah, so I'm all putting together exercises, trying to scrape bits of data together to make exercises that I can give to other people with sort of legal data sets, and also thinking about like whether it's worth. I don't know. Once you get into training, there's all sorts of questions. You start wondering, should I be doing something online? Because everyone asks about, can I take your course online? Because otherwise we have to show up, obviously, to do these things. And the potentially is a lot of travel, and it limits how many people can do your thing. Pricing training is a real headache. I spend way too long with spreadsheets and post-it notes trying to figure out what things should cost. And whether we should be doing some sort of certification, or like whether there should be like a little test, and because people like getting certificates and putting things on LinkedIn and so on. So I'm like, well, maybe we should make something a bit more legit. And then maybe we should be franchising it. That's another thing I've been thinking, like to get it out there, right? Because otherwise it's literally just me, Evan, and Diego. We can maybe do 10 a year kind of thing. So that's where I'm all about that at the moment.
We talked about an interesting pricing model the other day.
What, pay what you can.
Yeah.
Pay what you want. Sorry, not what you can. It's like you can imagine a sort of Chevron being, well, we can pay $2.3 billion. Yeah, pay what you want. Well, a friend of mine says his pricing, what he tells people for when they ask how much things cost, is he says pay what you can and a little bit more, so that you to get people to sort of stretch and recognize the value and be invested. I quite like that idea. It worked for him for quite a while, but
I like the auction style of
sealed envelopes.
Available?
No. So it's pay what you want, but the person who pays the most gets something extra. Maybe it's another 5 hours one-on-one with their project and their data or something.
But who are they bidding against? Because I don't feel like we're that much in demand. I mean, I suppose we could create some scarcity around it by saying we're only doing 3 courses next year. Bidding is open on course 1.
Like bidding, it's pay what you want, man.
No.
You need a threshold level because you can't do it. You can't afford to do it for free.
Okay.
But there's a perceived value, like when things are priced highly. So,
but his things aren't priced highly. So
you should charge more, is what we're learning.
Yeah. Yeah, I mean, in a way, you sort of never get to find out, because I feel like we put our prices on the web actually now, because I was getting tired of sort of making an algorithm work every time kind of thing. So trying to, because I want it to be transparent. You know what I mean? I want to sort of balance transparency and fairness. And like, well, if you bring more people, then I want you to pay more, but I don't necessarily want it to scale linearly. But I don't want, like, you know, a third order quadratic function for people to have to figure out the price. So it's like,
you can't solve the pricing function. You don't preserve it.
And then people, well, then people are like trying to, as soon as it looks like there's an algorithm, like a non-linearity, then people are trying to optimize, right? So people are like, oh, well, what if I like add one more person, but we do one more day, then the price goes down, and then I can have, it's like, okay, this is not what I envisioned when I set up a simple model. It's tricky.
Yeah, interesting. It's kind of similar to how we are trying to grow our business. Like we give out referral credit to people. So if you refer a friend to our service, then you get some money off for your next order. And so from that standpoint, if you have one person who represents a company and they bring in 5 people, maybe they just get, you know, five referral credits. And then it's all linear, I guess, in that sense. But it's directly tied to a person, and so maybe it makes more sense for them. I don't know.
Yeah, no, I like that. I mean, because that's what you want. You want to build in an incentive for people to teach more people, and do more, and go to new levels, right? And do more courses, basically, not just because we get paid for it, but I mean, that's the point of what we're doing, is to sort of build skills in a big layer of people. And so yeah, I like the idea of sort of, yeah, maybe it's not quite like a loyalty program, but something that rewards investment. Yeah, it's I guess just a perennial problem. But if it's unique every time, and it's like, well, what are you trying to achieve, and how big you, because this is like a lot of people in our business, in the oil and gas business, base their prices for things like software and even services on the daily production of the company, right? It's like, oh, well, if you know, if you're doing 1 million barrels, oh, then you know,
so you should charge more.
we should charge more.
Yeah.
Yeah, well, I mean, that's basically what they do. If you're a big company, you're going to pay us more because you can, and they're completely. I don't know what their prices are, but they're transparent about that aspect of it. Yeah.
When I was interviewing for data science jobs my first time around, I did this data science project where I looked at private tutors in New York City, and this is kind of a similar scenario where you have tutors that charge a lot, and parents go and look online at this tutor's profile and they see, oh, this person's charging $250 an hour. They must really be good.
Right.
You assume that other people are paying them that. And once you get one person who pays you for that, then you can say, yes, other people do pay me this amount of money. And it was a very weird marketplace because the prices were all over the place for what people charged. And there was, well, anyway, I tried to build a model to kind of predict what people would charge, and it failed miserably because everybody was charging whatever they wanted. And then that just kind of told you should charge more.
Yeah. No, I remember when I left Halliburton, and Halliburton, I'd been in the business maybe 6 years. That's how much experience I had, and I was charged out, well over it was about like 2,500 US a day or something like that was like the day rate, and people were signing 1-year contracts for a service level like that, and obviously when I went out on my own, I was like, wow, if I can capture even half of that, I'd be well happy. But I asked around, like, what are some of my friends were sort of for hire interpreters, seismic interpreters and stuff. And there's this one guy who's like 20 years experience, really awesome guy, great interpreter, 800 Canadian a day. I was just like, well, this is so weird. Like, it's like a random number generator. It's like practically a new grad basically being charged out at, I don't know, at the time, that was probably 4 times what this guy was charging. And you just feel like that guy's clients were probably like, whoa, sweet. I hope this guy never finds out what other people are charging, kind of thing. But not sort of taking him to one side and saying, you need to quadruple your prices.
Like the most inefficient marketplace.
Yeah, with people just feeling silently aggrieved because they're paying too much, or silently pleased because they got a great deal. The clients feel, it's just, I don't know, doesn't feel very efficient, like you say.
Speaking of courses,
nice.
I'm giving one, apparently.
Oh, cool.
When is it? April 27th.
What is it?
It is how do you classify, or how do you make inferences about your customers' customer journeys using PyTorch? Woo. Yeah, it'll be cool. It's basically like an intro to PyTorch if you really care about using it for something that's going to affect the business rather than just you want to get into machine learning, right? So that'll be neat. It's in Austin. I don't know. There's a link in the show notes. I don't even know where it is yet. I actually just found out that someone signed me up for it. Nice. Anyway, should be fun.
Sorry, you're teaching the course?
Yeah.
You just found out that someone signed you up to teach the course?
Yeah.
Hey, I signed you up for a course. Oh, cool. Thanks. That sounds great. What's it on? It's PyTorch. You should really like it. Cool. Yeah, all your students are going to be really thrilled. Wait, what? Yeah, that's cool.
No, I think it should be fun. I mean, I get to write the material, so it's going to be zany, and keep it fun, keep it fresh, keep it light. Okay.
I like it.
You ready for the next section of the show?
Oh, it has sections?
Yeah. This is the section where we have Ethan give us. So, oh man, this is how I should have done it. Speaking of courses, again, nice. Ethan's thinking about building a recommender system workshop.
I am. I forgot that I told you that.
Yep.
Yeah.
You can't tell me anything unless you want it live on air.
I think I told you that when you got to the apartment at 2 a.m.
I did. Well, I hadn't been drinking, so
one of us.
So if you were going to give that, let me rephrase that. You're going to give that course right now.
I submitted an abstract to give this course, and I have not built the course yet, but I have written a bunch of blog posts.
This is it. This is it.
This is it. for
Okay.
free.
This is like a mini MOOC right here.
Exactly.
We promise to put the link to your course signups whenever it's ready, whatever.
It gets accepted.
What's collaborative? Oh, so, okay, you ready?
What's it going to be? It's going to be an online course, is it?
No, I submitted a workshop for ODSC, Open Data Science Conference, I think it's called.
In Boston, there's 3 of them.
In Boston, yeah, there's 3 of them. This one's in Boston. It's at the beginning of May. And so I submitted a workshop where I would kind of walk from the very beginning to kind of modern methods of recommendation systems. So we'll see what they say.
Very cool.
But maybe to start with, I feel like I should define what a recommendation system is.
Okay.
For your audience.
Nice.
There we go. That's probably how I'll start the course as well.
Nice. So you want to take notes while you do that?
I should, yeah. You just take notes,
Okay.
and then we'll.
It's all up here in a steel trap.
Yeah. So recommendation systems are things that I deal with a lot at my job, and things that I guess most people have seen while perusing various websites. So probably the best example is either Netflix or Amazon. So let's say you go to, you look up a book on Amazon, and towards the bottom, there's a carousel, kind of like a slideshow of other books. And it says, people who bought this also bought that. There's an algorithm that generates that list of books. And that's like a recommendation algorithm. Another example is when you sign into Netflix and you see all of these movies that are being shown to you by Netflix. They actually decide which rows of movies they show you, and they decide what is the order of the movies that are in those rows. And all of that is done via a recommendation system.
So they must take a survey about the things you're interested in, like sci-fi movies or horror movies, and then make predictions based off of your categorical votes.
Sometimes.
No?
Sometimes they do. But actually, the dominant way that these algorithms are trained are off of your usage data. So if we were to look at, let's say, Amazon, that would be what have you bought and what have you viewed on their website. And if we were to look at Netflix, it would be, what shows have you watched and what shows have you watched the most of.
You're telling me that you can make recommendations based solely on only what I've done, and I don't tell you anything about my demographics?
Yeah, it's actually kind of freeing, right?
Whoa.
So you have machine learning models, right, where you build out a classification algorithm or a regression algorithm, and you have to spend all day kind of manufacturing these features. So maybe I want to predict what is the price of a house, and in order to do that, I have to know, how many floors were there, what was the square footage, how many bathrooms, and all of these other inputs into my model.
Dead bodies in the basement.
Dead bodies in the basement, probably going to lower the price. And in those scenarios, it's actually kind of a pain because usually data lives in a database somewhere, and it's maybe kind of dirty, and it's a pain to query, and you have to kind of turn all of that data into numbers to input into an algorithm. But the nice thing about recommendation systems is at least to get a pretty good one off the ground, all I need to know is like, who are you and which products have you looked at? And then just with that, we can kind of design this entire algorithm.
What if you know something about other customers who've watched the same movies as me?
That is quite helpful. And so, well, maybe let's back up a bit. So you did, well, I do want to draw a distinction between kind of what data people tend to look at. So I think oftentimes if people are familiar with recommendation algorithms, they think of things like how many stars did this get on Amazon, and things like ratings. And kind of famously, Netflix had this $1 million prize where they had a giant data set of what had certain customers rated certain movies and TV shows. And whoever got the highest score on this ratings data set got $1 million. And it's kind of a big deal at the time, but it turns out that nowadays kind of nobody looks at what people rate things. And if you go on Netflix now, it used to tell you kind of a star rating for these shows, but now it just gives you a percent. Like, how much of a match is this for you? They'll say, this is a 98% match. And so kind of the difference between these two systems, when we look at things like ratings, that's called explicit feedback, I guess. And that's the customer telling you, yes, I like this, I liked it this much. And the other way, when we just kind of look at people's behavior, that's implicit feedback. And so nowadays, everything is based off of implicit feedback. And I think kind of the best example of this is that, let's take Netflix again. Somebody might tell you that they rate Citizen Kane really highly, but they might just want to watch the Kardashians all day. And we should be recommending things that they want to watch. And so...
But which one of those things would they think they wanted to watch, I guess? Because I can imagine do you know what I mean? Like maybe it's an aspirational like.
Totally. Yeah.
And watching the Kardashians is like, I've given up because I can't find anything to watch.
Yeah. Do you want an algorithm to kind of tell you TV? Like maybe you don't want to be reminded of it.
Yeah. It would be cool if you could choose the model that was recommending things. Like I would like to model the best version of myself today. Tomorrow I would like to model the worst version of myself. Which which junk food do I like when I like junk food?
It's a good point that you bring up. And in some ways Netflix is trying to solve this. And we've been doing this at work a lot as well, because when you go onto Netflix, they give you the reason why they're recommending things to you. So each of your different rows of shows, one of them might say like strong female lead, or gritty pop drama, and they're telling you like they've learned that you like this, and they're presenting this as this is the reason why you think they might think that you'll like it. And by them getting to have multiple rows, they might have like critically acclaimed movies and reality TV, and then
yeah, you're right. Actually, that I've noticed that, and I've noticed it especially with YouTube for some reason. They seem to do a really good job of those sort of segments, and the recommendations seem quite good, actually.
Yeah, theirs are
realize.
Quite great, and they've released some papers actually on how they work, which is pretty cool as well. At least, yeah.
So with the ratings, do you think was the obsession early on with ratings because there wasn't the data to support doing it any other way, or was it because it felt like it should be the right way to do it? It somehow felt like a purer signal.
It's a good question. I came into this field after the decision had already been made, but I think there's a couple of reasons why ratings were focused on. I do think that people thought that this mattered, which seems reasonable. But I also think so. There's some algorithmic issues with dealing with implicit data, and then there's some computational issues as well. So from the computational side, actually implicit data is great because there's a lot more of it. So for example, I don't think I've ever rated a product on Amazon, but I've definitely bought lots of products, and I've definitely viewed lots of products. So you get a lot denser data with implicit data, and that's good from a recommendation side. But 10 or 15 years ago, that might have been quite a pain to handle at scale for companies, kind of before the rise of big data and things like that. And so that's one part. The other part that's really hard is that with explicit data, all I care about is what the items that people have rated. And that's a reasonably sparse amount of data. If I think of every combination of a user and an item, they haven't rated very many. But with implicit data, the way that you're supposed to handle it and the way that the algorithms handle it is you say, okay, somebody viewed this item, they probably have a preference for it. But for the items that they didn't view, we don't really know that they don't like these items. And so we actually have to kind of factor, we know that they might have less of a preference for them, but we kind of have to factor in every combination when we train these algorithms. And so you end up having to kind of deal with the entire dense data set of all of these uninteracted items.
What kind of sparsity are we talking about?
So typically for implicit feedback, the sparsity, it's typically less than 0.1%. So if you imagine a matrix where every row is a user, every column is an item, and the entries in the matrix are, let's just say, whether or not the user interacted with that item, whether or not they watched it or they bought it. Typically, less than 0.1% of those entries are actually filled. And the goal of the algorithm is to kind of predict all of the missing values. But with implicit data, you have to play some algorithmic tricks to be smart about how you handle the fact that you need to deal with kind of that entire matrix. And so there's been a number of papers that came out. One of those was during the Netflix prize that came out as a way to kind of handle this.
Hmm. And I also wonder to what extent these algorithms can learn sort of abstract attributes of things so that they're not, if you look at a lot of, I don't know, kitchen appliances, that they don't become obsessed with food mixers, but of expensive food mixers or beautiful food mixers. Do you know what I mean? Like, and so if you then go and look at, okay, I'm digging a hole for myself here, but if you then go and look at power tools or something, it's like this is the kind of person that wants to buy quality products, made in Japan or the USA and not China or Korea or something like that. Like, does that kind of attribute transfer, do you think?
Yeah, it can. It doesn't always. It depends. It all depends on the data. But the idea behind these algorithms is that they're extremely flexible. And typically how they're done is via this thing called matrix factorization. But the basic idea is that, let's say for a given user, you've gone and looked at all of these different items, and the algorithm learns how to represent you as a vector. And let's
sum of your parts.
Let's say like a 20-dimensional vector. It kind of learns the vector that represents you the best. And it learns that vector for every user and every item in the data set. And so you can kind of play tricks with this where you can measure, like how close is your vector to all of these items in your data set. And you might find that your vector lives close to lots of expensive items. And so when we kind of run that analysis after the fact, we learn afterwards that you tend to like expensive items.
Yeah, I guess it's a kind of analogous to the strong female lead action movie documentary.
Yeah, the hard thing is interpretable.
Yeah, right, exactly. So the features aren't necessarily, or the dimensions aren't necessarily interpretable. Are people making attempts to try and interpret them? I guess because that would be quite interesting for designers and people like that, right?
Yeah, so I think there's kind of two ways to go about it. One way is you just start clustering things and you observe and see what pops out. And so because you now have a vector that represents everything, there's lots of clustering algorithms to kind of cluster this continuous data. And so, but that requires it's fairly manual in some sense, that you build these clusters and you look and see what comes out. The other thing that you can do, which is pretty fun, is if you have other information about you or other information about your products. Let's say we know the price of the product, or we kind of chop the price of products up into bins. So we have under 25, 25 to 50, etc. With these algorithms, you can actually learn a vector that represents that price bin. And that vector will live in the same space as you and the items. And so in that scenario, we can measure the distance between you and the different price bins, and which price bin do you live closest to. And so now we're back to feature engineering, where we have to kind of define these things by hand, but that gains us some interpretability. And I keep saying vector. In the neural network world, these are called embeddings. There's also, sometimes they're called latent factors. There's like lots of names for all the same thing, but the idea behind all of it is that you're kind of learning vector representations of these things. Manifold learning.
Let's just be explicit again. though we mentioned it before. If you haven't played with these systems before, it is fascinating. You sometimes do, sometimes don't decide how long the vectors are, but you don't decide what the vectors represent. You don't like, as opposed to a classification algorithm, you don't say this is color and texture and size and weight. You just, your hands off, and it figures, it learns whatever features it needs to learn.
Yeah, and then it's up to you to go in afterwards and figure out what the hell happened. So
yeah, right. So you're still at the clothing company? Yes. Yeah. So it isn't possible to then sort of say, here's the, for an individual user, like here's the archetypal wardrobe for that person, or to say, given our customers, these 3 products will sell better than any products we have in our current range. Like that you can't, can you make that kind of reverse inference?
You can,
Yeah.
like if I wanted to look at, which 3 products will sell the best, if I can predict the probability of a customer purchasing a product, I can then look at all of our customers in that month that we expect to send products to, and I can calculate what is the likelihood that each of them buys every single item. And then we can kind of back out from there what will the top selling items be.
Are your designers aware of this trend?
Yes. Yeah, it's an interesting question. We like to work more in that, well, you kind of have it from both sides, right? Because the designers, they have an opinion, and they are able to look out into
Sure.
the
right. Yeah, okay. That's interesting.
What does the algorithm think will be good as well? And so ideally we're working in both directions.
Okay, so that's interesting because potentially, and this is maybe I'm reading too much into this, but I mean, my conviction is that these algorithms can help the humans who may perhaps feel threatened by them, can actually free them from some of the more difficult or mundane aspects of their work, to think about the bit that it's very difficult to design an algorithm to do. In the case of a designer, they can just think about the future. They can just think about, trends and zeitgeist, and use the algorithms as a filter for, they no longer have to try and figure out what will sell, right? You can do that bit. The high risk, potentially less interesting part of their work can be kind of automated, and the fun creative part where they can just go crazy with designing 20 things a day and then just putting them through the sieve of Ethan to see what's going to sell.
Yeah. I mean, I like the idea of freeing people. Of course, usually if people are
not freeing them of work.
Yeah. Usually, I feel like it will require fewer people in the end. I do agree.
Yes.
One thing that you touched on is something that we've been focusing on a lot, which is really to, like, there's definitely a minutia of a job that an algorithm can do better in order to help out the end user. And so, like, as an example, the way our service works is we have a stylist who goes into kind of an internal e-commerce store, you can imagine, and they pick out 5 items of clothing that they think that their customer is going to love. And the goal of our algorithms is not to replace the stylist. Like, I am never going to be able to build algorithms that are as good as a stylist at being able to pick up on all of these things and have this opinion about clothing. But like, there are things that we can help the stylist with. So as an example, that stylist, they could look back through the customer's feedback, and we have our customers rate products and say, this fits small, this fit large, I loved how this fit, and things like that. And so the stylist can kind of look back through all of that feedback and try to see, oh, the customer complained that this was fitting small a little bit. But we can have an algorithm that says with statistical confidence, things tend to fit this customer large. Then it can just surface up that information and kind of free the stylist to not have to, have that cognitive load.
Yeah, right. And you know, I feel like there's all sorts of ways in which you can kind of have this. I guess people call it like augmented intelligence or things like this, where I don't know really how your service works, but you can imagine a scenario where there's someone like a stylist who has perhaps some finite set of clothes, maybe they've been designed or they're in this wardrobe or whatever, to choose from. But then it's like, well, I need some socks or a tie or a scarf to go with this. And a computer can conceivably go look at 300 clothing websites and examine 90 million articles of clothing and go, hey, these three things would go really well and the customer would really like them. I kind of like the idea that they could, you know, there are corners of a task like that are impossible to essentially to do well as a human, and like let's find, and maybe we've ignored them because they're impossible, right? You know, in some aspects of our work we've just said, well, that you can't do that. So
we're getting a little far out there, and there's one more thing. Unfortunately we're running late on time, but there is one other thing I wanted to touch on before we go. We're going to skip over all that stuff.
These 3 pages,
and we're going to get to the last question, because this is one that I'm interested in. So
yeah,
we mentioned the words matrix factorization, but without going into too much detail, tell us how that is more of a sort of deterministic setting where this other thing, and then I'm going to reel you back in, and then we're going to talk about the other thing.
What do you mean by deterministic setting?
Okay, so let me just
set up the question.
Let me just start with the second thing. So people are using things which approximate deep learning systems to perform recommendation algorithms. You actually wrote a blog post on one, as I recall. And I'm wondering how these new systems differ from traditional methodologies like matrix factorization.
Sure. So I think I know what you're getting at. Yeah. So what we were talking about before, where we have users, we have items, we learn vectors for them. That is kind of this classic notion of matrix factorization. And then I talked about how we can also add in other information and learn vectors for these things. And what you end up starting to build is you end up kind of in the world of deep learning at this point. And it turns out that you can take a deep learning library and you can do matrix factorization using that library. Back in the day, people kind of had to write these bespoke algorithms in order to kind of optimize these sorts of models. And the beauty of deep learning is that you just run stochastic gradient descent on whatever you throw at it, and hopefully things converge if you have big GPUs and lots of data. And like that same thing is true now in recommendation systems. I think in the past year or two, it's kind of really hit the mainstream, just as we've had all of these deep learning libraries come out. And so you can do matrix factorization with deep learning. You can add in extra information, but kind of everything else that people do with deep learning, you can do that with recommendation systems now. So I want to take an image and use that, like use information about the image in order to generate a better recommendation. I can do that. But then you can go even further because we have these sequential models in deep learning, these kind of like, let's say, time series problems and things like that, where kind of the order of your data matters. So things like LSTMs, recurrent neural networks, and people are now doing that with recommendation systems, and it kind of makes sense. Like YouTube actually, one of their papers talks about this, and when you go on there, the order of videos that you watch on their website changes the recommendations that they're giving you. And that way they're kind of able to really zero in on what do you want to watch right now, as opposed to what have you watched over your entire tenure with YouTube. And it's actually really creepy how good they are. So anyway, that's kind of like, that's like the frontier of recommendation systems right now, are these temporally aware systems. and
so that
it's
gets
super fun.
I'm really fascinated by this, and that gets to half of my point. The second half of my question is related. So when I was writing these questions down, I was thinking of time as a continuous conditional variable, right? So the other piece of that puzzle is, how do you incorporate discrete conditional variables, or something like or like sort of equivalently like a Bayesian prior. So specifically, if I want recommendations on dresses, or if I want recommendations on pants, can I use the same recommender system and just flip a pants bit?
Yeah, you can. Actually, there was a recent paper from YouTube on this, where they consider, I guess this is generally called context. So another example would be like time of day. So like, what do I want to eat at what time of the day? If I wanted an algorithm to recommend me my meals, then it's going to recommend different things in the morning than in the evening. And so, yeah, basically you can build out features. Like one way is you can kind of build out these binary indicators around, let's say, is it morning, like middle of the day, or evening?
Okay, and so this is what we touched on before.
And then we can incorporate that into our model as a feature.
Okay. Is that, I was, if that's the way it's done, that's the way it's done. I was thinking more of like altering the latent space itself.
So sometimes another thing you can do is, let's say you learned a vector, like an embedding representing the time of day. And let's say you have a deep neural network. Kind of at each of those hidden layers, you can interact, or let's say dot product, or like you can add that vector on to all of your hidden layers. So you could add in the time of day vector to kind of the hidden layers as you propagate through. And so you're going to kind of traverse a different path due to this context. And so that way you can kind of control the paths that you go down.
That's fascinating.
Yeah, I'll put a paper in the show notes around this. It just came out.
Good. I think both of you guys saw on Twitter the other day, I'm interested in doing some sort of conditioning of latent spaces. And I didn't know, and it sounds in this case like exactly the same thing happens, right?
Yeah.
That's fascinating. Matt, what are you reading right now?
I actually just finished a book by, it's definitely one of my favorite authors. He's called Magnus Mills. Don't know if I might have mentioned him on the show before, but I haven't read one of his books for a while. This one came out probably a couple of years ago, but I only just got around to reading it. It's called The Field of the Cloth of Gold. And if you like, he's not really like anybody, but it's a bit like Kafka, I guess. His worlds feel like a kind of weird parallel universe somehow, like an uncanny, slightly alternate version of what I think of as almost like I guess they feel quite English. He's English. Maybe it's an English thing. Difficult to place in time. Maybe like the 50s or something. I don't know. They're very strange. No one writes like this guy. People call it darkly comic, but it's not laugh out loud funny, but it's, I don't know. They're very compelling, weird books.
What are the stories about?
The
most recent.
I guess they're about order, I would say. The guy, I feel like Magnus Mills is probably a bit of a OCD, maybe slightly or something. They're sort of about order and the disturbance or dysfunction of orderly systems and what then happens. So some of his books, one of his books was about buses and buses running on time. And that's basically the entire theme of the book. There's another one about keeping animals confined, but you don't know what the animals are or what happens if they escape. or anything. It's just really weird. There's another one where a guy like, oh, I don't know, they're very difficult to describe, these books, but they're really good. If you want a kind of a slightly off kilter fiction quick read, because most of them are pretty short, look him up. Magnus Mills.
Sounds fascinating. Probably one of the best book recommendations we've had on the show. Man, I'm getting one. How about you, Ethan?
I'm trying to read The Vital Question. Is that what it's called?
Yes.
Yeah. So I think Graham recommended it to my dad, who recommended it to me. I haven't finished a nonfiction book in probably like 8 years.
Oh, wow.
For whatever reason, I'll read a textbook and I'll read fiction, and I can never get through nonfiction books. And so I'm about a third of the way through.
Power on, man.
I think it's good. It requires a lot of effort when I'm reading it. I know nothing about biology. It's kind of like about how life exists in the universe, but it kind of covers all aspects of that. So it covers the biology, of course, but then also how can life exist, from a physics standpoint, kind of from a fundamental physics standpoint. How can we support this, and how can cosmic environments support this? So it's definitely far out and dealing with questions, but I'm slogging through. So I'll probably, I'll be on your guys' podcast in like a year, and hopefully
it'll be 2/3 of the way through.
But I've told myself like I need to finish this because I definitely started a lot of nonfiction books and I have not finished them. So this one I have to finish.
Here's one that the book I'm reading right now is one that you might be into, Matt. It's called, actually, you've probably already heard of it. The rest of the world heard of it, and I was the last one to find out. It's called Enlightenment Now by Steven Pinker. Have you heard of
it? No.
Oh, yes, I wasn't the last one.
Second last.
Yeah. It is a brutally optimistic look at humanity, the human species, and how far we've come and how well we're doing. And it is quantitative. I mean, it's impressively well thought out and well proven that that despite the negative media coverage and the unhappiness of individuals and things, that quantitatively measured in almost every aspect of humanity, we are the best we've ever been.
We can't stop winning.
Are we tired of it? Are we tired?
I don't read a lot of books like this. I don't read a lot of optimistic pieces, and I'm trying to not like this book. But it is so well proven.
What are the metrics that define?
It depends. It depends on what he's trying to measure. So, for instance, one of the concrete examples he discusses is infant mortality, right? And so there have been for hundreds of years at least some record of numbers of infant mortality, and that is plotted in his book and discussed per region, per time. That's one little miniature, tiny example, but it is really amazing, and it's so it's not a mathematics book by any means. It's written, anyone can read it, but it is very well put together, very well documented, and it's highly recommended.
What I think of him as like I don't know, like a linguist or something. What is he?
I have no idea. I didn't know anything about him until I was the second to last person on earth to find out about this book.
Not that people are defined by their disciplines or anything, but like cognitive psychologist, linguist, popular science author. Okay.
So he has in the preface to the book, he has acknowledgments, and almost half of the acknowledgments go to statisticians and data scientists. So I think he's upfront that he was not the one who put together the statistics in the book.
Right.
and he attributes every conclusion to its source, and
credit where credit's due.
and
Good.
he's just sort of weaving the tapestry, right? So I don't know. It's wonderful.
I'll start it in a year.
Yeah.
Rack them up.
Okay. Before we go, I wanted to say, hey Google, turn the lights purple.
Please. Well, it works.
Yeah. So we're out of here. See you next time. Undersampled Radio. Thanks for coming on the show, Ethan.
Thank you.
Yeah, cheers, Ethan.